Morning, folks. So today I want to start part 2 of this Sansui AU-11000 rebuild process. As I mentioned, I want to take a little different format on this. Having you watch me solder parts, and I think it's boring. Plus, I'm too distracted to do a good job between tripping over the camera, not having my visor on, and tripping over the cat that's always underfoot. So with that in mind, I want to revisit the boards I've already done and then talk about some of the other boards I haven't done yet, how to get them out, what to replace on them, particular parts when I feel it's pertinent. So with that, let's go to the first board. Okay, so this is the F2568, known as the power supply and protector board. I'm not sure why they call it the protector board, because the protection relay is on another board that we'll be talking about next. This board does plug into it, so perhaps that's what they're referring to. But anyway, you can see I replaced all the electrolytic capacitors. Also replaced several small signal transistors that are known to be problematic as they age. By the way, I don't know if I mentioned, I started this board because it was so easy to remove. Just take one screw out, this bracket comes out, board unplugs. There's a list on a popular audio forum that I'm a member of the worst transistors that you change out on site. They're usually small signal transistors that get noisy with age or become failure prone. So we change those out as a matter of course whenever we rebuild anything. Something to note on this particular board is these large cement resistors had several bad solder joints on the back of the board, which I reinforced with cut jumper leads that I keep in a drawer. They had broken through the solder joints. They weren't making good contact. I'm really not sure how this thing was still working. In any event, that's what was done on this board. Small signal transistors, capacitors, and fix the bad solder joints. So I'm going to put the schematic up here, and you can see the before and then after. These are the components that were all changed out. The transistors used to change these were, for the NPNs, we used KSC 1845s, and for the PNPs, we used 2SA or KSA 992s. Okay, next up we have the F2582. This is known as the power supply circuit board for the driver amp. And that is this guy right down here. I finished the first board, the F2568 regulated power supply and protector board, put it back in to test it, and then I had to take it right back out because it plugs in here. In order to get this board out, I had to take that board out. No problems. If we look at the schematic on this, you can see all the parts that were changed out, but one thing you won't see on that schematic is I also changed out the protection relay. Now that relay, let's see if I have the bag here. That relay is an Omron MY4-02-DC24. Now you can use these in a lot of Sansuis. Some of them you'll have to cut a row of pins off. This particular board has holes in it to accommodate the unused set of pins, so there's no cutting of pins on this relay. This is a drop-in replacement for this amplifier. And as pointed out, I changed out all the electrolytics, changed out the relay. Somebody had fixed a crack in the board before. The work didn't look bad, so I left it. And of course, we checked all 4 of these fuses to make sure they had the correct value. These resistors had not cracked the solder joints on the board, so that was good. And when I put this board back in and went to test the amplifier, because I've seen some people strip these down to the chassis. I don't do that. I would rather do them one board at a time and test in between. And in this case, I'm glad I did, because when I put this board back in and went to test it, the amplifier would not come out of protection. And after a couple of preliminary checks, it's really easy to know if you have offset in any power supply stage by just checking with your DMM and volts mode from ground to any one of these cement resistors. Just pick one on each channel. That's all you need to do. And you'll see if you have any kind of egregious offset that will keep the amp in protection. In this case, the amplifier modules were fine. Took a quick look at the schematic, realized I didn't have a voltage coming in because there was a black wire here that, was that the one? Yes, it was this one that I did not solder back in. It had gotten buried down in here and I didn't see it. The visual inspection didn't show it, but once I realized that I had no voltage at that point, oh, I stand corrected. That was my ground. In any event, this is what my problem was. So this board had been done, and interestingly, one of these capacitors was so bad, I've never seen ESR in the megohm range, but one of these was just completely shot. So I don't know how this wasn't making a lot of noise, but everything worked. However, and I'll show you this later on, after I finished up doing the driver board for the output stage, the imbalance that we had seen earlier disappeared. We'll get into that later. So anyway, with this board, once I connected that wire, everything here worked. And then I went on and did the Phono board, which is the F2570. So we're going to take a quick look at that. By the way, this would be a good time to mention that if you are tempted to order all your rebuild parts from the service manual, to please resist that temptation. You will find as you look at these boards that quite often the parts on the board do not match the service manual. This is due to the fact that a lot of revisions are made during the manufacturing process run, and that can cause parts to change, and the manuals are rarely revised. So the gold standard is whatever was installed at the factory on your board is what you want to replace using that value. For instance, if we look at this schematic, it says that C3 is a 10 microfarad 16 volt bipolar. What was actually in there was a 3.3 microfarad bipolar. C7 shown as a 0.047 microfarad, most likely polyester, was actually a 1 microfarad non-polar electrolytic. C15 was correct on this schematic, and this board, they were 3.3 microfarad bipolars. By the way, Sansui tends to use this scheme when laying their manuals out. You'll notice that all these part numbers are odd. The even ones will be the right channel. All right, so next up is the EQ board, the EQ circuit board, the F2570. I did these 3 boards because they were the easiest ones to get to, and they all have to be done, so it really doesn't matter what order you do them in. So on this, I replaced the polyester input coupling caps with polypropylene, which are lower distortion in this application. And there are a lot of dual transistors on this board that needed to be replaced. I'll show you what one of those looks like. But they were replaced, since they were PNPs, with 2 KSA 992s that were soldered together, and you had to put them back to back in order to solder those. I think I mentioned that in the previous video. And those guys look like this. And I remember showing you this. They pin out base collector, emitter, collector, base. They were replaced with two back-to-back KSA 992s. A lot of the low leakage electrolytics were replaced with film capacitors through here, which are excellent caps for this application. Whatever few electrolytics on here were replaced, and that pretty much completes this board. We'll take a look at the schematic here. You can see how it looks, and now you can see what I had replaced on here. This tested out fine first time. So the next thing that I'm going to tackle is the output driver board, and that's the new one that you haven't seen yet. Like I said, I worked these from easiest to hardest, and the last ones we're going to have to do necessitate pulling the front panel so we can get down into all these boards down here. Okay, next up is the driver amp circuit board. Now this unit is fitted with the F2583, not the F2580. So be sure if you're looking at the schematic in the manual or trying to troubleshoot this, you're looking at the right one. Now this is easily removed from the unit. All we have to do is pull these connectors, another one that comes in from the other side underneath the board, and remove these two screws. So I'm going to pull this out so we can take a look at it. Now, I've taken pictures of this, and I highly recommend you do the same. You don't want to get any of the connectors screwed up. A lot of them are keyed, but just to be safe, take pictures. It's free and easy. Okay, let me reach under here and pull out the other connector. And I'll show you where that goes when we pull the board free. And that's all it takes to get this guy out of here. Okay. Okay, and you can see I've already done a lot of work to this. So let's take a closer look at the board itself. On this board, of course, all the electrolytics were changed out, and you can see them. I forgot to order these 3.3 microfarad on my last Mouser order, so I'm gratified that this comes out easily. I'm going to have to order them on the next order and pull this board out again to replace those. All these driver transistors have been removed, and new micas and heatsink compound have been applied. I also changed the polyester input coupling capacitors to polypropylenes for added distortion. Changed out some of the older relays, changed out the VD1212 bias relays for two 1N4148s in series, and also changed out all these transistors. These transistors are known as uniwatt, ostensibly because they will handle 1 watt. These are not TO220 cases. They look sort of like them, but they are known as uniwatts. Now, these are known to be problematic in these units, and these were replaced with the onsemi KSC 3503s and KSA 1381s. And that is what all these are here. Now, they're all the same color. I always like the fact that the older ones used the color scheme, that the black ones were NPNs and the green ones were PNPs, but as long as you watch your P's and N's, you'll be good. So all those were replaced. I also replaced the input differential pairs with matched, I believe they were KSA 992s. I'll have to take a look and make sure what I used here. Yeah, like I can see that. Yes, these were KSA 992s. Now, one other thing I did is always recommended whenever you rebuild something like this is that these older open frame trimmers were replaced. These are for bias and offset. And in the old unit, if you take a look at this photograph, they were kind of a pain to get to. They're buried in here. You can see two of them, and two of them are so far down you can't even see where they're buried. So I made one minor modification to make my life and the life of any future tech a little easier, and that was to place these on the back of the board. Now the back of the board is visible when you have the side panel off, and it just takes a few screws to get that off. Then you can be working on this, measuring the voltage drop across the emitter resistors to get your bias set, and turn them right from the top. And I'll show you what I mean. By the way, I want to mention this. During the initial disassembly of this amplifier, I found this odd looking piece. Now I thought it was part of the power switch because it was missing the entire back part of it, and I've never seen one of these power switches. But I couldn't really see how it fit there, so I put it in the bag, and as I was disassembling the amp, I realized when I pulled this driver amp board that if we look right here, these are the slots that the amplifier board sits in. That's what that piece was. So now that I've found where it goes, I just found another screw to put in here, and now it has both brackets inside here. So you can see with the board reinstalled, or at least sitting in place here, that I can get to the emitter resistors down here, and all my pots are easily accessible right here. And like I said, it only takes a few screws to get that side cover off, and I feel this was a real improvement. It certainly made my life a lot easier when I went to test the board and I wanted to rough in the bias and offsets. Okay, so in the next videos, I'm going to start tearing into all the boards that lay behind the front panel. We're going to start going deeper and deeper in here. I will post them. Please let me know in your comments if you find this newer format a little more easy to follow. Certainly easier for me to do. I can concentrate on the rebuild and then walk you through all the steps I've taken. So until next time, thanks for watching, and I enjoy giving back to the community that has given me so much. Thanks a lot, folks.